right, oh my goodness. Let's get started. It's this spring break can't come soon enough. I'm ready for a break right now. We got 2 more weeks. We're going to make it, but oh man. All right, so quick PSA before we get started today. The lab exams are a lab. I don't even know if I'll get it through this one day. The lab exams, the lab quizzes, are an exam quiz environment. Make sure you are not using any outside resources. It should be you and your quiz, and that's it. No looking up any outside resources, no going to the course website, watching course videos. Anything besides the quiz being on your screen is an academic integrity violation. We will start policing this. So this is your fair warning that we are going to watch for this. And if you're caught doing this, you will fail the course. We have a list of 71 students, I can't believe the number is this high, across all 4 sections that have been accessing outside resources. If you're still doing this after this warning, it's going to be an F in the course. We're not messing around with this. We are going to start cracking down. There's your fair warning. Don't do that. Like, I don't know how 71 of you think it's okay to be on other pages than the quiz. By the way, it's pretty easy to detect this. You're dealing with people with PhDs in computer science. We can figure out when you navigate away from the fucking page. Like, I teach a web development course. We can do this pretty easily. Now this is, Paul and I talked about it. We're like, do we really fail 71 students, just out of the blue like that? We decided it's a little bit much. So here's your fair warning. Paul's doing the same thing in all his sections. You're caught again, it's done, out of the course. F in the course. And I usually don't like the AI meetings. It's not fun telling someone they failed, but the people who are not even paying attention during this warning who are going to fail, I don't know. I might enjoy those meetings a little bit. Because come on, not showing up to class or showing up and not paying attention and distracting other people is far worse. I didn't mean to go on this tangent, but it's far worse than just not showing up. Just don't show up. What the hell? It's college. You don't have to be here. Okay. I'll go a little further on that tangent since I started. You don't have to be here. We always design the grading policy, at least in my course. I always design the grading policy so that if you get 0 for lecture questions through the semester, you can still get an A in the course. So attendance is technically optional. If you know your stuff and you don't need lecture, don't show up. But you better actually know your stuff and get all the AOs throughout the whole semester. But if you can do that, I'm not going to force you to be here. But if you do show up, you get some consolation AOs. If you're going to show up and work at it and show me that you're trying, you're going to get some AOs for that. But nobody has to be here. Anyway, I didn't plan on going on that tangent. I went to go on the AI tangent, the AI rant today. We went on a different one. And we want to talk about inheritance. Still talking after I just went through that. Wild. All right, so let's talk about inheritance. Any questions on that, by the way, before we get into it? I don't know what questions you could have. I'll find out. What? Personally, that's what I would do. I would have a fresh window just for the quiz and not have any risk. That's what I would do. That's not required as long as the quiz window, the quiz tab is the one that's in focus. As soon as you navigate away from that tab and something else is showing on your browser, then that's when you're going to get caught. But if it were me, I would be safe. I would close down everything on my browser, get a new browser window, and just have the quiz open. I don't want any meeting where I'm like, hey, you navigated, you cheated during the quiz, you're using outside resources, and somebody says, oh, I was trying to click and my finger slipped and I accidentally clicked a different tab. I don't want any bullshit like that. So if you have multiple tabs open, you're running that risk, and I'm going to treat that as a bullshit excuse, and you're going to get an F anyway. Yeah. We'll have to, take that into consideration. We'll be careful with our detection. Yeah, it's a good point. Make sure we watch for that. Yeah. This comes up every semester. I forget, we decide, the TAs and I and Paul, we talk about it every semester, and I forget what we decided for this semester. The question is, what should you do? You're done with the quiz, you're just sitting there waiting for your interview. What do we expect you to do? First of all, we're not logging your stuff after that. Once you submit your quiz, who cares? But for the AI conversation. But what should you be doing, and what are you allowed to be doing? I think we decided this semester that you can't, browse the internet and kind of sit there patiently, unfortunately. I know that kind of sucks, but my favorite countermeasure to that, my counter to that, is to make the quizzes longer. For what it's worth, Paul disagrees with this. He says, let's make them no longer than they have to be. But I say, well, we have 2 hours minus the 10-minute interview. Let's make them an hour and 40-minute designed quizzes. So for what it's worth, I lose that battle. So you can sit there patiently, or you can take basically a midterm exam for every one of these quizzes. Sitting there patiently, I hope you agree, is the better outcome. So yeah, you just got to sit tight. I think that's exactly what we agreed for this semester. Sometimes I say that you can. One semester we did say that you could browse the course website and study for the interview, but that just caused all kinds of other issues. So I'm pretty sure we axed that one this semester. Have an hour and 40 minutes. We should be able to just load that thing up with questions. But anyway, luckily I lost that one for everybody's sake. The TAs didn't want to grade those either, for what it's worth. I was the only one who, it wouldn't increase my workload, and I was the only one pushing for it. Okay. Which I do. We like to run a democracy, by the way. If the TAs overrule me and Paul, we usually concede to that. We'll say, you know what, that is a bad idea that we had. All right. Any other questions before we get into it? Inheritance. Let's talk about this. Okay. So when talking about inheritance, I want to talk about it through example. So we're going to build some functionality of a game. Now, we're not going to build the entire game. Unfortunately, we don't really have the lecture time to go through entire game design. But we are going to build some of the functionality. We're going to build a game with health potions and weapons and players can use either one of these items. And we're going to simulate what that usage actually means. Okay, so let's talk about the health potion class. We're going to create a health potion class. This is going to have an XY location as doubles. This is going to be the location in the game world. We're thinking a 2D game. I always imagine this game as a top-down 2D grid-based, but you can have floating point locations, so you don't have to be exactly on a tile. You can move around in this 2D space. So we have an X location, Y location to get our XY coordinates, and a health potion has some variable that measures the amount of health that will be restored when this health potion is consumed. And then when we use this health potion, we're just simulating with a print statement right now. When we have a player class, we can have this increase the HP of that player up to their max HP if increase is high enough. Right now, we're just printing to the screen to simulate that. That's it. That's the health potion class. But we've done all that before. I think I can get away with just that quick 1 minute or less review of how to do this. We have 3 instance variables, a constructor that initializes all 3 variables, and one method that uses part of the state of the object, the increase state for that behavior. We've done all that. We've been doing that for weeks now, so nothing new here. If there are questions about that, I'd love to hear them, but I assume that we're all beyond building this class at this point. This is one of the simplest classes we'll see or build on the homework assignments. We all agree. Oh, I almost forgot to mention this. The task 4 assignment is out. Those of you who did start it already, I did have a typo when I first released it. It is array list, not linked list, in the compare array list method. It was a really silly typo. It was compare array list something something, but I accidentally had the parameters. It said takes 2 parameters of type linked list. It was supposed to be array list to match the method, the one that made sense. So I had a silly typo, but I did see the first few submissions coming in all had linked lists. I'm like, why is everybody using linked lists for that? It was my typo, that's why. But I did fix that typo. If you're one of the people who already started, make sure you update that to array list and get your credit. I was driving myself nuts looking through one submission. Like, what are they doing wrong? Everything looks perfect, but they're getting a 0 and a compilation error. That was it. It was my typo. Sorry about that. We did get it fixed. All right, so what are we learning today? This is our review. What are we learning today? Of course, inheritance. It's inheritance week. Everything this whole week is going to be about inheritance. So let's talk about what inheritance even is. And let's rewrite our health potion code to use inheritance. So with this, we still have a health potion class, but we're going to have it inherit some functionality from another class called game item. We're going to put some of the functionality of the health potion class into the game item class. And let's break down how this works. So game item is going to have some of the state and behavior of the health potion class. We're going to put that state and behavior in this separate class, and it's going to have everything that any game item, whether it's a health potion or not, any game item in our game should have. Right now that's location, and that's mostly what it is going to be in this example as we build it out. But game item, every game item should have a location in the game world, no matter what type of item it is. So let's take all the location-based code, which right now is our X and Y location and a constructor that initializes that location, and put it into the game item class. And then in the health potion class, we're going to leave everything that's specific to health potions, this one type of game item. So we have this separate class. I got ahead of the slides a little. That's going to contain all the location code, X, Y location, and a constructor to initialize that location. And for what it's worth, no way of updating that location at this point. And then we're going to extend game item in the health potion class. So in health potion, we're going to use this keyword extends, and this is going to trigger our inheritance. When we see the keyword extends, this means health potion inherits from game item, and this is our inheritance. We got a lot of vocab here. We're going to inherit all of the state and behavior of the game item class. When we extend or inherit from game item, it's as if all of the code in the game item class was in the health potion class. So we're going to add all of the game item state and behavior to the health potion class with this extends game item. So all the state, we have these 2 instance variables. When we extend game item, these 2 instance variables become instance variables of the health potion class. So health potion explicitly has the increase instance variable, but it inherits X location and Y location from game item. So every health potion is going to have 3 instance variables, even though 2 of them were not declared inside that class, they were inherited from another class. So X location, Y location are both instance variables of the health potion class through inheritance. And we also get all the behavior. Right now the behavior is just a constructor, but we're going to eventually add at least one more method to this. One more method today and then more methods as we move on throughout the week. So we inherit the constructor as well. So this constructor does exist inside the health potion class as well. So we inherit all the state and behavior just as though all that code was typed into the health potion class. We have more vocab. Superclass, subclass, parent class, and child class. Kind of 2 sets. It drives me nuts when we have vocab like this, where there's 2 sets of terms for the same exact thing. But we say that health potion is the child class of the game item class, and game item class is the parent class of health potion. Or game item is the superclass of health potion, and health potion is the subclass of game item. So if I say subclass and superclass, I mean the same thing as child class and parent class. That's how we describe the relationship between two classes when they are when we're using inheritance like this. And I'll sometimes use these interchangeably. As much as I just said, I don't like when there's two sets of terms. I do sometimes use, depending on the context, one of them over the other. Can you extend more than one class? No, never. Just for clarification, the extends allows for instance variables from one class to be applicable to another class. Yes, and also all of the methods. So the instance variables and methods all get inherited. You can't extend more than one class. If I say extends game item and also extends something else, not allowed, at least in Java. I should qualify it like that. There are some languages that allow that. Java does not. If we want to have multiple inheritance, then we have to use something called interfaces and implement multiple interfaces. That's a topic for Polymorphism Week. We're not going to talk about that this week. Also, abstract classes. Some of you might expect that to come up pretty soon. We're actually going to save that for Polymorphism Week as well. So we're only going to talk about classes, interfaces, and abstract classes. We're not going to see quite yet. We're not going to see those this week, so we can focus on just inheritance. When I used to cover inheritance and polymorphism and all those topics all in 1 week. It's just too much. So we tried to scale back the inheritance week and get this out in a little more piecemeal, because this is a pretty heavy topic when you first see it. Inheritance is a tricky topic to get a grasp on. What's the main distinction between extends and import? Extends and import, I wouldn't connect those in your mind at all. Those are two completely different things in programming in Java. Extends means we're using inheritance. So the health potion class gets all of the state and behavior from the game item class. Import says we have this other class somewhere else that's written somewhere else, and we would like to create objects of that type or use its static methods. We want to use that class in our code. Like the array list, we never extend an array list, but we will import an array list because we want to use that class as is. Extends is when we want to take a class and add more functionality to it through another class. And whenever we have inheritance, whenever we see the keyword extends here, the superclass constructor must be called. Must. This is going to be the thing that I'm going to repeat probably the most throughout this whole week, through this week and Polymorphism Week. The superclass constructor is always called when we're using inheritance. So right here, and we use this syntax, super, and then call the constructor as though it were a method. We inherited game items constructor through inheritance. We inherited this constructor, and to call it, we use the keyword super. We use super as though it were a method, and that's going to be like in replace of game item. We're calling the game item constructor, but through the keyword super, and then just calling it, giving it the parameters. This is going to call the game item constructor that takes two parameters. We're giving it two arguments and calls that superclass constructor. This has to happen, has to happen every single time, 100% of the time in Java. The superclass constructor is always called. It is never not called. That's important because when you're doing your memory diagrams, you better have your superclass constructors there. That's the part that I'm going to remind you of over and over and over again. If anybody doesn't do that on their memory diagrams, I'm going to find you, I'm going to come after you, because I'm going to say it so many effing times in lecture. Your superclass constructors, do not forget your superclass constructors. They are always called. So we have to make this call. It takes X location and Y location. So we're not passing increase to the superclass constructor because it doesn't have an increase parameter here. We're just going to forward X location and Y location to this constructor so we can get these instance variables initialized. There's a special case where if the superclass constructor doesn't take any parameters, then it can be called implicitly. So if the superclass constructor takes no parameters, we don't have to put super open paren, close paren. Java's going to be able to figure this out. Like, there's no parameters, there's no arguments to give the superclass constructor call. Java's going to be like, I know you're going to put super open paren, close paren, semicolon. That has to be there because it's forced to be there by Java. So Java's like, you know what? I'm not going to make you type that. I'm just going to implicitly call the superclass constructor without you having to put any code there. The superclass constructor is still called. It is still called. Even though we don't call super right here, the superclass constructor is always, always called. Because this is how we're initializing the object. This is how we're initializing the instance variables from the superclass, is by calling its constructor. So all the constructors through all the inheritance has to be called. We have to call that superclass constructor. And this is probably the biggest point. We get all the state and behavior, and the superclass constructor has to be called. Those are probably the two biggest points for inheritance that we need to know right now. So this superclass constructor is still called, and I can take this a step further. If you don't have a constructor in your superclass, that means you get the default constructor, and that default constructor is still called. The superclass constructor is always called. Even if there's no visible code that is performing that, it is always still called. Even if I delete this constructor and leave this code as is, the game item default constructor is still called. Missing a superclass constructor on your memory diagrams, that's an easy fail. Easy fail. Especially with how many times I'll say it in lecture. Easy fail. Does a superclass constructor come before or after the main constructor call? Before. So the superclass constructor call always has to be the first line of your constructor as well. So that's why Java can assume, without having you type this, there's no information for you to give it, because it has to be the first line, and if it takes no parameters, it's not going to take any arguments either. And your superclass constructor can't be after the first line in your constructor. So it's always the first thing that the subclass constructor does is calls the superclass constructor. So do we call both the superclass constructors and the set methods? It depends on the setup. If you're thinking of task 1, if you're saying this in the context of task 1 where I say call set title in your song and movie constructors, I say that because when I say make the rateable class, it doesn't have to take any parameters in its constructor. It's actually up to you. If you want to have rateable take a title as a constructor parameter, then call the constructor, or have it take no parameters and call set title. It's either or. You don't have to do both. As long as you get that superclass instance variable set one way or another, it's up to you. It is up to you. Because I'll never call the rateable constructor directly in my testing, so you're free to design that however you'd like. Yeah, the superclass, its constructor is taking the parameters for the parent class, yeah. Because a game item doesn't know anything about increase, so it can't do anything with increase at all, but it will handle, it's responsible for X location, Y location, so its constructor can initialize those values. And it really should initialize those values. Yep. No. So if I didn't initialize these, if I didn't have this constructor, or if I explicitly made the default constructor empty, I just deleted what's highlighted here, they would be initialized to 0.0. This is something I don't like to do in 1.16, but Java has default values for each of its primitives. So the default value for a double will be 0, 0. So when I initialize, or when I declare this variable, it will get the value 0, 0, and then I'm overriding 0.0 with 0.0 in this case. So it's redundant, but it's making it clear what's happening here. Ints is 0. I shouldn't have started listing things. It's because the next thing's Boolean. Boolean, it's either true or false, I forget, but it's one of the two. I got a 50-50 shot of it. It's true. It's initialized to true. If I'm wrong, oh well. That doesn't work with objects. It kind of does, but any object that you don't initialize gets the default value of null. So including your strings. If you don't initialize a string, it's going to be set to null. So you can get in trouble there. You'll start getting null pointer exceptions if you're not careful with that one. But your primitive values, they all do have a default value that they'll be initialized to. I don't like doing that in 1.16. I like being explicit. In some languages, including C that you'll use in 2.20, does not have any default values for its variables. Its default value is whatever happens to be sitting in memory, in the memory address that was allocated, or the memory addresses that were allocated for that variable. So it's whatever garbage is sitting there in memory that was used for either your program as it added a stack frame and then deleted it. The stack frame isn't actually deleted. It's just marked as deleted. So all that garbage is still there in memory, and that's what it'll be initialized to. So don't get in that habit. I wouldn't get in that habit because that's a Java-specific thing and other languages. But C and C++ don't do that. Anyway, made you insert type out super. You have the same code as I do on the screen right now. You have this same code. This should be fine. But, oh, am I in big mode? I'm not even in big mode. But that's not going to be a quick thing. I didn't leak anything there. Let's do this. Let's take a little detour. I don't do enough live coding. Well, last week was all live coding, but let's get some more live coding in here. So if we go to game item, I'll just remove the constructor completely. So I'm getting the default constructor, and X location, Y location will be 0, 0. Health potion, I can't have this anymore. I can optionally do this, but it's not going to make me write that. If I delete this, I'll still get the same exact effect. And go one better. I'm going to set a breakpoint here. Run this in the debugger. Because it's going to take me to every class that extends. Oh, there's only a couple. Debugger. So I'm in the health potion constructor. When I step into... I set the breakpoint a little earlier. There it is. So I can see that I do go into the game item constructor. There is no constructor, but I do get the default constructor. So I do go into the game item class, call the default constructor, which doesn't do anything, but the instance variables are still initialized when we go into that constructor, and then we jump back out to the health potion constructor and then finish initializing things. But even though there's no super call explicit, there is no constructor in game item, we do still go into the game item constructor, the default constructor, and initialize those instance variables. That still does happen, and we don't need that super call to be explicit. But this does the same exact thing. If we have the super call here, it's the same exact thing that we just saw. It's just explicit instead of implicit. Big mode. A little bit of a detour, but worth seeing. We're seeing the visual of what this is saying. Okay. So if I don't like to, but it's fair game too, if it does show up on the quiz, having an implicit super constructor call to a default constructor in the superclass. If that does show up on your quiz, make sure you're still getting the superclass constructor call. That always is happening. Superclass is always called. Okay, so those are the two big things. We inherit all of the state and behavior from the superclass, and the superclass constructor has to be called every single time, 100% of the time. Always called. So those are the two big things. But why the hell did we do this? This was more work. We have more code, more work, and way more confusion because we have to understand what inheritance is to accomplish the same exact thing that we did with the health potion class. With the original health potion class, I said, we've been doing this for 2 weeks. That's easy. It was just instance variables, a constructor, and one method. That was nice and simple. And now I've gone and complicated things by a significant amount. and made the code harder to read. I have to jump around to 2 different classes, which will be in 2 different files, to be able to accomplish the same thing. So why would we ever use inheritance? Now that I showed you what it is, let's talk about why we would ever use inheritance. And I'll give a brief spoiler. The biggest benefit, in my opinion, to using inheritance is polymorphism, which we won't see for another 4 weeks. So that's where I'll really get the big selling point of why inheritance. But even without polymorphism, there are some pretty big selling points, some pretty big advantages to using inheritance. So first, it doesn't make sense if we just have health potion, but when we do have more types of game items, that's where we start to see the benefits. So in the spec, I said we'll have health potion and weapon in this class. Once we have 2 classes, we start to see a little bit of the benefit. So with this, we have 2 different classes that both extend game item, and now both of these classes, weapons and health potions, both get this location information from game item. They both get the XY location instance variables, and they're initialized without having to cut and paste this code in both both classes, because our alternative would be copy this from health potion, paste it in weapon, and then add the weapon specific stuff. Which admittedly isn't that bad with this example. Where it gets even more powerful is when we want to add methods to all of our game items. If we add a new method, now we can actually move things around the game world, some dx, dy, and move a game item in the game world. I want to add this behavior to every single class that extends game item. I just put that method one time in my code, write it one time, and now let inheritance send that method to every single class that extends that class. So weapon and health potion both extend game item. I add a method to game item. Weapon and health potion both have the move method now, and they can both move around our game world, only having to write that code once. With the cut and paste method, you're writing this code one time. You're copying it and pasting it in the other class. With 2 classes, not that bad. But you release your game, your players are running around drinking health potions and using weapons on each other, and they're like, this is fun, but I really would like it if we had grenades in this game too. And hundreds of other feature requests. We want lots of other games to be able to set traps. Maybe we have damage tiles. We want to add a lot of features to this game to actually make it interesting. We have lots of different game item ideas that we want to implement in this game. Well, every time we come up with an idea, we're going to create a new class, extend game item, so it can get all the game item state and behavior that's common to every game item, which can include things like being able to be placed inside the player's inventory, be able to be thrown and apply physics to these things. Maybe they'll have some mass and keep track of their velocity and their momentum and have a physics engine be able to track them throughout the game. All this code can be common to all game items. And then when we create a new game item for our class, we just have to think, okay, I want to add grenades. Extends game item, so it is a game item and has all of the state and behavior of a game item, but also now when it's used, it's going to create splash damage. And then I just have to focus on that grenade-specific code that I have to write, and everything else just comes along for the ride through inheritance. That's where it becomes powerful, especially when we want to edit one of these methods. So with move, it's not too bad. This method might not change. Actually, it will change. We want to add a z-axis to this thing and change this to a 3D game. Even if it's still going to be a 2D game for the user, if I throw a grenade, I want that to have a nice parabola shape when it's thrown. Whether that's visible to the user or not, I would like to use that to track how its trajectory is going to go. Where is it going to land? Well, I'm going to use a physics engine and track its vertical, its height, in addition to its XY. So I want to add DZ to this and add a Z location and a Z location here. And I'll default the Z location to 0 so I don't have to update all of my other code for what it's worth. I don't want to have to go through my hundreds of game item classes, make that change in one, and then copy and paste that change to another. And then there's one game item that I missed, and now I have a bug in my code because one type of game item doesn't have a Z-axis, and I have code somewhere else that's expecting a Z-axis, and now when gravity is applied to that game item, it's not applying properly, and everything breaks. Instead, I just want to change that in the game item class and just let it all cascade down to all of my other classes, no matter how many of them there are. If I have thousands of game item classes, I don't care. I'm going to make one change one time and let it cascade through everything. And when it comes to testing, because your team should require testing when you're out there building things like this. We don't like releasing bugs, even though bugs do get out there in production. We don't like releasing bugs. So if I put that code in the game item class, I test the game item class, and now I know once that's tested and accurate, I know that it's correct in all of my subclasses instead of going to each subclass and writing tests for every single one of them just to make sure that I don't have that copy-paste error or there's not some weird interaction between them. I'm not going to do that. I'm going to test it in the game item class. Okay, so that's the big advantage of inheritance is what we're effectively doing is factoring out the common functionality between multiple classes, factoring it out into a separate class, and then having each class extend that common class to get all the common functionality. You do inheritance from class A, where class A inherits from class B, and like a class extends a, wait. I thought I knew where you were going, and then you switched it up. Or maybe my brain just can't handle this. Can you do inheritance from class A, where class A inherits from class B? So A extends B, like a class extends A, and in A, class extends B. So A extends B and extend A, and then this class can get the instance variable from A and B at the same time. I feel like this is worded strange. I think my guess of what you're going with is, can I have A extends B and B extends C, and then A gets B and C? I think that's what you're trying to ask. And the answer is yes, you can absolutely do that. But why can you just import all your classes? Why can you? You can import whatever you want. Yeah, import all your classes. Can the child class act as a parent class to a different class? Can a child class act as a parent class to a different class? Yes. Yeah, and that's the ABC question. So I can have, like, weapon here. It's pretty vague. What's a weapon? I might want to narrow that down a bit more and say class sword extends weapon and have multiple steps in the inheritance. So if I have sword extends weapon, extends game item, then sword will get all of the state and behavior of weapon and all of the state and behavior of game item. It'll have all of that state and behavior. So going back to the multiple inheritance question, you can, in that sense, you can have a chain of inheritance, but you can't extend multiple classes from a single class. You can't say sword extends weapon and game item. You wouldn't be able to do that. Yes. Yeah, and so when you have a chain in inheritance like that, A extends B, extends C, extends C, D, extends E, all the way through that chain of inheritance, every constructor is being called. Every single constructor in the whole chain of inheritance is being called. But can't you import all your classes instead of using inheritance? I mean, it's just a completely different thing. Using inheritance, the weapon class is getting all of the state and behavior of game item. If you import game item, so you could import game item and then have private game item as an instance variable of weapon. It's similar, but it doesn't accomplish the same thing. The game item instance variables aren't part of a weapon object. It has to go to another object and access the same behavior that way. Sometimes that's the right thing to do, called composition, but I don't know how to say it. It's just not the same thing. Because, let me do it this way. If I have this move method that's inherited, now weapon, I create a new weapon object. Weapon equals new weapon dot move, and I can move that weapon directly. If I don't do inheritance and I just import game item instead, I could have a game item object as an instance variable, and then I'd be doing weapon. Like, how am I going to call that move method? I do weapon dot, I guess, get game item dot move, and then the XY location would have to be of the weapon would have to be accessed through that instance variable. I'd be transferring my logic to that instance variable all the time, it would end up being extra code, like like this would turn into new game item. I don't know. I feel like it would just be a mess doing that. Game item, it would be an extra getter at the very least. And then people could get a reference to that game item object and then modify it without us being aware of that change. It'd just be a mess. But yeah, just trust the directions. Just trust it. Inheritance is going to work better in a lot of cases. All right, let's do a memory diagram. We're not going to use the tracing tool for this one. Aside from the superclass constructor, there's no new syntax, no new memory diagram stuff. But I want to illustrate what the new stuff is going to look like and focus on the concepts of this one. Plus, every time I've gone to the tracing tool, I spend way too much time doing it, and we never finish. So I want to try to go back to the slides and do it this way. So let's trace this thing and pay attention to these two things, the superclass constructor and which method is going to be called. That's the other part of this. It's going to be important in your memory diagrams and in your code and in your whole career whenever inheritance is used, is what method is called. So we're going to create a new weapon class. We're going to focus on the superclass constructor and then call two methods on this thing and see what method is called in each time. For this one, it's pretty trivial. There's only one definition of the use method and one definition of the move method. We're going to explain why each one is called. And then on Wednesday, there are going to be multiple definitions and overrides, all kinds of good stuff. We're going to do a little more work to figure out which method is called. But first, superclass constructors. So we create a new weapon. Everything's as usual at this point. We're going to create a new weapon. All of the parameters, constructor parameters, go on the stack frame. The weapon object is going to be created on the heap. We get a reference. That reference is stored in the stack frame. This is a reference to the object that's being created. And that's all the same. We've done that 100 times by now. And it's only been 2 weeks, but we have done it a lot of times in those 2 weeks. Has it only been 2? Oh, plus we had the testing week. So I guess 3 weeks ago we learned what classes were. That still seems fast. But now it's going to get a little bit different at this point. So when we create a new weapon class, we don't just get the instance variables from the weapon class. That's how it worked before. But now that we inherited two other instance variables, we have to get all of the instance variables from all of the classes, from both of the classes in this case, into the weapon class. So we created damage, X location, Y location. All three are instance variables. X location, Y location were inherited from game item, and damage was defined in the weapon class itself. The first thing that's going to happen after that is the superclass constructor call. Don't forget your superclass constructor calls. Superclass constructor call is the first thing that happens, and it is another constructor call. It is another stack frame for this object creation, and this in the superclass constructor call is still a reference to the one object that's being created. So even though we have two constructor calls here, we're still only creating one object. One shorthand, if that's a little trippy to you, some shorthand you can think of is right here. We are calling a constructor, but not with the keyword new. We're not creating a new object. We're calling the constructor and applying it to the object that's already being created. Yep. Still do that. Yep. Yep. So in the example where we did not have any superclass constructor parameters and we didn't write super here, this line of code was gone, these were both gone, and X location, Y location, we both initialized to 0, you would still have the superclass constructor call. It would only have this. It would just have this OX350 with no parameters because the constructor wouldn't have any parameters. But that stack frame would still be there for that constructor. Always, 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 100% of the time. I think that's a little too tricky on the quiz to put that on, because that will be an instant fail. You miss a superclass constructor call, because without the superclass constructor calls, the inheritance quiz is pretty much the classes quiz. Like, that's the new thing. That's about it. That and overrides, knowing what method is called. Those are the only two things we're assessing. So if you miss one of those things, like that's an easy fail. Like, sorry, but that's you got to know that. So I think it's a little too tricky since it is an instant fail to make it implicit. But if it is, if we do put that on the quiz, which is fair game, but if we do put that on the quiz, make sure it's still called. Superclass constructor is always called. If you see extends and we're creating a new object of that type, there's going to be more than one constructor call for that object creation every single time. Okay, so we got the superclass constructor call. It works just like any other constructor call, except it's not creating another new object. 2 constructor calls, 1 object. And then we go through the superclass constructor, initialize the values, and then go through the weapon constructor, initialize damage, and then return a reference to the object that's been created. So that's what I mean by superclass constructor call. That's what it looks like in your memory diagrams. This looks pretty much identical to the way it will in the tracing tool as well. I just didn't have to sit here for 5 minutes typing this X location, Y location damage, this X location, Y location, X location, Y location damage, references and everything. Goes a lot quicker in the slides. Okay, now don't forget your superclass constructor calls. It's a less common mistake since I started repeating it so many times in lectures, but I used to only say it like 5 times, and then like half the class would fail because of that. So I say it enough times that it's not as common of a mistake. Yes? I wouldn't be mad if you don't have a return arrow. In the tracing tool, there shouldn't be a return arrow because there's no variable for it to return to. And here, if you had a return arrow that pointed to the other constructor call, I wouldn't be mad at that. But no arrows are required for it. No return arrows. Inheritance can fix your marriage. Have you tried? Yeah. So this would be in the main method. So in the tracing tool, this would be the main stack frame right here. In the tracing tool, either way is fine because we wouldn't even know when you submit whether you created the weapon, when you created the weapon variable.